Local arena, 10 applicants interested in working in the snack bar. So they decide they can hire 4 people. Does it matter if you get hired first or you get hired third? No, you still have the same job. Where would the order matter? Well, if they decided the first person, we're going to pay you $150 an hour. Second person, $75 an hour. Third person, $10 an hour. Well, can you do that? No. What's minimum wage? $11.65. Okay, third person, $11.65. Fourth person, you get Sturgeon Heights Collegiate Volunteer Hour. Right? Then it would matter the order that you got hired. But if they're hiring you and you all get the same amount, the order doesn't matter. So one of the things that's going to happen when you read these questions later on is you have to first decide, does the order matter or not? Should I go to my permutation strategies or should I go to my combination strategies? So here, if we decide the order doesn't matter, well, then I have 10 applicants. I just want to choose 4. 10 choose 4. Go to my calculator. And I get 210. I'm going to leave a space there because I'm going to write something in here afterwards. Then in B, it says, oh, it's going to be really busy at the arena. We need to have 6 people working, not 4. So now we do 10 choose 6. And we find out the answer is also 210. So one of the things that's going to happen with your combination formula, because I said you're going to use your combination formula a lot. Yes, you can type it into your calculator, but on your formula sheet it says this: NCR is n factorial over n minus r factorial r factorial. That's what your formula sheet says. So what does that mean when I plug things into my formula? If I have 10C4, I would have 10 factorial on the top because that's my n. For my r, I'm going to have a 4 factorial on the bottom. And then the other number is n minus r. And this is where you're going to be able to do this really quick, because you're going to notice that the bottom 2 numbers always add up to the top number. So 6 plus 4 is 10. So 10 choose 4 is just 10 factorial over 4 factorial, 6 factorial. And 10 choose 6 would be 10 factorial would have a 6 factorial, and what would add up to 10? A 4 factorial. So I hope you can see that it makes sense that those 2 numbers are the same from the formula. Now I'm going to show you with a visual example why they're the same. I'm going to take 10 cards and imagine these are the 10 applicants. If I randomly choose 6 of them, these 6 get the job. What do I have in my other hand? 4. Every time I make a unique group of 6, I'm left with a unique group of 4. So if I was counting groups of 6, does it make sense that it's the same as counting groups of 4? Because every time you count a group of 6, you're also counting a group of 4. If I make a new group of 6, there, I make a new group of 4. Every single time. And so if you count all the unique groups of 6, that will be the same as counting all the unique groups of 4. Okay? So I've seen you're going to get questions later on that say this. 12 choose 7 equals 12 choose what? What can't equal 7? What number could be there? 5. Does it make sense? If you make a group of 7 from 12, you always make a group of 5. So then in this case, the question mark equals 5. Or if I say k choose 8 equals k choose 3, what's k? K would have to be 11. Because if you make a group of 3 and a group of 8 and they're the same, you would have had to have started with 11. Okay, questions for practice on this one? 8 and 10.